Hi there, this is a battery tester kindly sent in by TOPDON for review. I'm not paid for the video, but since I'm allowed to keep the tester, I marked this video as promotion. From previous reviews, you know that this doesn't stop me from sharing all my findings with you. The tester has the interesting name of ArtiBattery101, AB101 for short, and is an entry model as far as the TOPDON battery tester range goes. That's fine with me, as the higher end models are probably more something for garages or serious car enthusiasts. From the blurb on the back, it supports a variety of battery types and testing standards, but it's only good for 12-volt batteries. Very different in all these aspects from the Kelvin tester I reviewed a while ago, but common for both is that the tester is directly powered from the battery under test. Another thing that's different is that this tester comes with a proper manual hiding between the two sheets of the cards in the back, so be careful if you cut the plastic pack open. My manual is all in English and 12 pages long. It's not bad and does give some advice on how to interpret some readings. The display is a bluish monochrome LCD screen that does support a limited graphic mode. The value at the bottom is the battery voltage and updated in real time, which is a very useful feature. The navigation is done with the usual 4 buttons. The main menu has 6 items. There are 3 different tests. You can look at the last result, change language and look at the serial number. Although not written anywhere, you are expected to start with the first test for a new battery, because only that test brings up the battery type and test standard selections. Once that is done, the other tests are using whatever was selected here. The tester remembers what you selected even after disconnecting it. If you are still testing the same battery next time, you can simply press OK to use that value. The battery types are what's shown here, all lead acid technology, no lithium. 2 types of AGM or absorbent glass mat type of batteries, which is confusing because the manual says if you're not sure about your battery, select AGM. Right, which one please? I reckon the flat type may be more common and that's what I picked. EFB is an enhanced flooding battery I have not come across yet. I am no expert in automotive battery technology nor in testing standards, because once the type is selected, the next thing is to pick the testing standard out of 10 choices. It starts with the CCA or cold cranking amps, which you are familiar with from my review of the Kelvin BM550. I leave the discussion of these various standards to the expert and guess you should pick whatever you might find on your battery. A quick interruption here. My lack of knowledge on this topic is obvious because when shooting this I found a GB standard. I thought that's for the UK and I was delighted to see it uses familiar amp hours, which is also written on most batteries here in the UK. Only when editing did I find out this is in fact a Chinese standard for electrical vehicle batteries. But no, I'm not going to do all my tests again, because I reckon it's not too far off. Instead of proceeding with the test, the tester warns that the power is too low. How does it know? The only thing it has seen so far is the voltage of my power supply standing as a battery. I assume with power, the tester means voltage, and it's nearly, but not quite 12 volts. Anyway, about 10 seconds after the OK to proceed, the results are back, together with a warning to repeat the test after the battery is charged more. I cover the other tests and the review options later. Just to finish off the menu, here are the language options. A choice of 6 are available. And the About screen shows that the firmware is V1-1.02 and some serial number stuff. Before testing some more, I want to know what's inside. 4 self-tapping screws hold the AB101 together, and once they are out, it's possible to pry the 2 halves apart without extra tools. The first thing I noticed, this thing has a USB port on the bottom. I totally missed that, probably because I wasn't expecting one. Then we have 2 very large 20 ohm resistors, which turn out are in fact in parallel, forming a 10 ohm load resistor. The clamps are connected using 4 wires, which means they are probably of the Kelvin type. The board is version 1v3 and dated 2022, not sure if it's 1st of April or 4th of January. Those 2 parallel load resistors are enormous compared to those tiny components in the upper right. The brain in form of a microcontroller N32G455, a 32-bit ARM Cortex M4 with the usual integrated IOs for digital and analog, and yes, it has a USB as well. A chip containing 4 op-amps in form of the MCO6004. I think this 6-pin chip is a dual MOSFET package, probably for switching on the load resistors. The PCB itself is not secured with screws, but it's not easy to get it out because it's held by those black grip strips and the USB connector. Anyway, nothing more to see, just the LCD and the rubber covers for the buttons. After putting it back together, I plugged in a USB lead with a mini USB connector, and sure enough, the AB101 powers up in USB mode. It shows as a pen drive on my machine, but it looks more like a utility for firmware upgrades. None of the buttons of the machine do anything. I asked TOPDON and they confirm that there's nothing that would be interesting for users in the AB101 USB mode, and no firmware is available either. Well, at least it has the capability to be upgradable. And after seeing the connection to the PCB, I examined the clamps, and indeed they are proper Kelvin types. The part with teeth is isolated from the rest of the clamp and has a separate wire going to the tester. This is the same arrangement as for the Kelvin BM550. And again, similar to the BM550, the AB101 tests that it's properly connected with both parts of each Kelvin clamp making contact. After the peek inside, I wanted to find out what it actually does during a test. Same way as I did for the Kelvin BM550 by using a scope to view the voltage drop across a 1 ohm resistor connected between the positive clamp and my power supply. You can just make out part of the resistor at the bottom of the screen. The scope is set to normal, not auto trigger, at 10 milliseconds per division horizontally and 500 millivolts per division vertically. For the whole test duration of nearly 10 seconds, the AB101 is causing current pulses. Running the test again with 1 milliseconds per division horizontally, the pulses are 2.5 milliseconds long, followed by a pause of 2.5 milliseconds. The pattern repeats after 5 milliseconds, so the frequency is 200 Hz, which the scope also confirms. The amplitude is about 1 volt across a roughly 1 ohm resistor, which means the AB101 is pulsing the current at about 1 amp. It is interesting that the screen of the AB101 shows a resistance of 82.23 milliohms, considering that I added a 1 ohm resistor in series with my power supply. This is the same problem I found with the Kelvin BM550. The testers are good for measuring very low resistances, but not so good for larger values, and in the world of battery resistance, 1 ohm is very large. Here's the same test, but I replaced the 1 ohm resistor with a yellow, fairly thick and short test lead. The result is just shy of 39 milliohm. Using a 220 milliohm resistor instead shows already more than 83 milliohms. The BM550 could measure that, not very accurately, but still. It only got seriously off track for resistors 500 milliohms or higher. The AB101 is way more picky in the limit of measuring high resistances. For an in-depth discussion on internal battery resistance and using AC versus DC to measure it, I have to refer you to my Kelvin review video. So far, you have always seen the AB101 complaining about the lack of power and caveating the results with retest after charge. Well, the difference is really 20 millivolts. Previously, the battery voltage under load that the AB101 saw was 11.98 volts, and now it's exactly 12 volts. The result is that the AB101 now recommends replacing the battery simulated by my power supply, because a 12 volt car battery after charging should have more than 12 volts. The AB101 reckons it has 0% charge. I decided to have a closer look at the way the battery voltage and state of charge are determined. First of all, the voltage the AB101 measures is increasingly wrong the lower the voltage gets, and at just below 4.8 volts the tester shuts down for good. No 18650 cell testing with this one. This is a tester for 12 volt batteries and nothing else. Also 24 batteries are out. The BM550 can do 6, 12 or 24 volts and is even usable for testing reasonably full 18650 cells. But then, while doing just one voltage range, the AB101 does it well. This is how accurate the AB101 measures the battery voltage. From 8 volts to 15 volts it's very accurate, far more than the BM550, which has to cover a far greater voltage range. The blue trace shows how the AB101 determines the state of charge. The voltage between 12.00 and 12.6 volts is converted into 0 to 100% charge. Anything higher than 12.6 is 100%, anything lower 0%. This is the same regardless what battery type or test standard you select. For comparison, the red trace shows the BM550 state of charge algorithm for 12-volt batteries. It uses a similar method but starts slightly later and never exceeds 98%. But the AB101 is not content with showing 0% for anything below 12 volts. From 5 volts to just below 9 volts, it refuses to do any testing and just tells you to go and charge your battery first. This is fair, it does show you the voltage, and all the other tests are designed for 12 volts batteries. They don't make sense to run that far off specification. From 9 volts onwards, it shows the familiar power to low, but it does the test if you confirm you want it. But then, as long as the voltage is below 11 volts, it does something different. A prompt whether you have charged the battery or not. If I say this is before charging, it tests again and gives us the data with the usual warning to retest after charging. If I run the test again but answer that this is after charging, it runs the test, but a 12-volt battery that had only 9 or 11 volts after being charged is definitely damaged, and therefore you get a bad cell warning. There's a similar behavior on the other side of the 12-volt baked into the AB101. If the voltage is higher than 13.3, you get a warning that the voltage is too high for valid results. This can happen if you test the battery right after it has been fully charged and before it had time to settle. The prompt advises you to turn on the headlights to remove the excess voltage. Clearly a lot of thought has gone into designing the software and make this as foolproof as possible. Having exhausted the battery test, I was interested in seeing what the cranking test has to offer. The AB101 connected to the car battery gives you 30 seconds to start the test, hop into your car and start the engine. If you don't make it in time or simply decide to do nothing, you get a test failed result. So let's do it again, but this time I changed the voltage in the power supply to simulate a drop while cranking and a rise once the engine is running and the alternator kicks in. I used a stopwatch to time my simulated cranking. Off we go. Dropping now. And now stop the stopwatch and at the same time back to higher voltages than before. I interrupt for a moment. I later did that test with a real car and discovered that the alternator signal has a lot of ripple. The tester uses this to determine that the car is in fact running and proceeds with further tests without the need for button presses. So this test here and the next one are not very realistic, and the tester rightfully expresses some doubts that the car is actually running. And the test passes with a cranking time of 6 seconds, which is exactly what my stopwatch showed. The third test available in the AB101 is the charging test. The engine is supposed to be running, but I just press OK in this simulation. It now shows a trace similar to a scope to see the ripple on the charge voltage. Just for good measure, I up and down the voltage a bit. The tester automatically proceeds to a load test and now wants me to press the accelerator to increase the RPM to 2500. To simulate that, I increase the voltage. The tester comes back with charging normal verdict. Nice. Apologies for the shaky mobile footage, it's hard to see, but I selected AGM flat plate and GB70 amp hours because this is a 68 amp hour battery. Outside temperature is about 10.5 degrees Celsius. Don't worry about the test now, the tester has it stored and I can review it leisurely back inside in the warm house. A real cranking test now. A message RPM detected shows that the tester knows the engine is now running. Charging test now. The engine is already running, of course. Wow, that's what I call real ripple. No wonder the tester did have doubts earlier in my simulation. Now the increase in RPM. The tester discovered that the engine revs are up and does its thing, much faster than in the simulation. Back inside, let's review the data gathered from the car. First, the battery test. My selection of 70 amp-hour GB obviously made it to a 560 amp test. No idea how that conversion was done. Anyway, the tester reckons the 9-year-old Volkswagen Golf diesel car with the original battery is still good for 427 amps and gives it a 58% healthy mark. The charge is relatively low with 25% and internal resistance 5.8 milliohms. The cranking test says it took 3.3 seconds to start the car and the battery voltage dropped to 9.24 volts during that process, ranking the performance as low. I doubt that the tester considered that this is a diesel engine which needs globe plugs, not spark plugs. Those need to go to temperature, which itself takes a lot of current and probably half of the 3.3 seconds. The manual does not mention diesel engines at all. The charging test indicates normal charging, which according to the manual is the best rating you can get in this test. Two more remarks on the review menu itself. First, the AB101 saves only the result of the last run of each test. If you run another one, the earlier one gets overwritten. Also, there's a finite limit of how many times a flash memory can be overwritten, but with only occasional use, it will be many years before that will become a problem. Secondly, I think saving the last test is a great feature, especially if observing and appreciating the test results under the engine hood is not convenient, but it requires that you have a 12-volt supply that the clamps are happy to connect to. Remember, these are Kelvin clamps. It would be great if TOPDON made the USB mode slightly smarter in that the review data is saved automatically as a file in the pen drive. That way, it could be examined or even saved without the need for complicated indoor power arrangements. While using it indoor, I couldn't help but notice that the AB101 feels warm to the touch. I put the tester onto a thermocouple and left it there. No tests or anything, the thermometer reads about 25.4 degrees Celsius. 10 minutes later and the temperature is 27.1 and still increasing. Just to show, the tester is just lying on top of the thermocouple, heating it through the plastic of the housing. The tester draws around 50.5 milliamps at 12 volts, which is quite a lot. I don't have a thermal imaging camera, so just careful probing with a thermocouple tip will have to do. I think this regulator is the culprit, which does not surprise me. 3.3 volts output from 12 volts means 8.7 volts difference to burn away. At 50 milliamps, that's more than 0.4 watts. Probably a bit less since there are polarity protection diodes which drop some of the input voltage. Anyway, not a big deal, the tester can handle it. I was just curious if the warming up was real or just in my imagination. I want to finish by comparing the AB101 with the BM550. Clearly the display of the BM550 is brighter and easier to read, but that's because it's just fixed symbols and segments, while the AB101 has an actual, albeit very low resolution screen made of pixels. The AB101 battery test takes around 10 seconds and the results are shown combined in one screen. It has two other tests and it caters for different lead battery types and test standards, but it can only do 12 volts. The one and only BM550 test process is faster at around 5 seconds, but since it can show only one value at a time, you have to click your way through the results. It only knows CCA as a test standard, but on the Plus it can deal with any battery from about 3.8 volts to 24 volts. To compare the results, I used the BM550 on the same car about 15 minutes after the AB101. The engine has not been started since the AB101 tests were finished. Three tests in a row, each with the AB101 and the BM550. The first two are on my desk with a power supply as a battery substitute. The most right is the actual car. For the first test, both testers were set to 500 CCA and the power supply to 12.5 volts. Both testers agree in their verdict that this is not a good battery. The actual results for SOH or state of health and SOC state of charge are different, which is not surprising since these parameters are not hard defined, so all manufacturers use their own algorithms. The hard values are the resistance and the battery voltage. The BM550 is a bit hampered by its relatively inaccurate voltage measurements. The AB101 is far more accurate. The resistance values are no more than in the same ballpark. I suspect that the AB101 is less accurate at these relatively high, for batteries, resistance. I verify this in my other video that the BM550 resistance values agree reasonably well with my measurements. The second test is using the same setup, but both testers were set to 100 CCA. This is more in line with what my power supply can deliver, and so both testers agree that this is a good battery. As for the values, the same applies as for the previous test. The last test is the recording from the tests on the actual car I showed earlier. Both testers agree that this 9-year-old battery is still okay. I'm happy to see that between both testers all parameters are much closer for the real car, showing, if nothing else, that my bench simulation wasn't very good. My verdict on those testers? I think for testing real 12-volt lead-acid batteries, the AB101 beats the BM550 hands down. It has more functions and at the same time offers more help, both in the manual and text prompts on the display for doing these tests, especially useful for non-specialists. The single drawback of the AB101 is that it only works for 12-volt batteries. But if you have a car with an aging 12-volt battery, the AB101 will prove very useful. The BM550 has no manual and its user interface has nothing to guide you in unusual situations. It only does a battery test, nothing else, but you can use it on 6, 12 or 24-volt batteries, and I like using it as a convenient way for measuring battery resistance, as I have done for nickel metal hydride packs and many recovered lithium 18650 cells. I would like to thank TOPDON for sending the AB101 in for testing. If you like my videos, don't forget to subscribe if you not have already, and maybe consider becoming a Patreon. That would really help this channel. The link's in the description. As a Patreon, you always get early access to videos, a blog and other exclusive content. Thanks for watching.